Hi there. Well, just as everyone was still processing the news about the discovery of 4 rocky planets in the Barnard system, astronomers made an even louder announcement. And this time, they literally stirred up the whole internet. The most cautious headlines I've seen describe the event like this: astronomers have discovered promising signs of a biosignature in the atmosphere of an exoplanet. So let's walk through this step by step. What actually happened, what biomarkers are being discussed, and whether we can really talk about alien life. Well, this guy has made everyone excited again. It's Professor Niku Madhusudan from the University of Cambridge's Institute of Astronomy. He's known for proposing a new class of planets back in 2021. He called them Hycean planets, a play on the words hydrogen and ocean. Hypothetically, these worlds have massive hydrogen atmospheres and could be completely covered by oceans. The key idea is that Hyceans could have liquid water, and therefore, they are good candidates in the search for life. Luckily, the characteristics of these planets actually allow for that, because unlike Earth-like planets, Hyceans are significantly larger and have thick, puffy atmospheres. This makes them better targets for the James Webb Space Telescope, which has a better chance of detecting the chemical properties of their atmospheres. At the moment, we know of about a dozen planets that could potentially be called Hycean, but one in particular is getting special attention: K2-18b. It's about 2.5 times larger than Earth and around 9 times more massive. And most importantly, it orbits in the habitable zone of its red dwarf star. So it's no surprise that ever since its discovery in 2015, it has been a target for the Hubble Space Telescope. The first big moment for this planet came in 2019, when a spectrum of its atmosphere taken by Hubble showed signs of water vapor. However, in 2021 and the following years, a series of studies questioned that discovery, suggesting the signal might have been affected by the spectrum of the parent star. Still, Niku Madhusudan and his team were interested in K2-18b ever since that first water vapor announcement. In 2023, they got observation time with the James Webb Telescope, finally allowing them to see the clearest spectrum of the planet's atmosphere. As a result, the name K2-18b returned to headlines around the world. This time, it was announced that the atmosphere contains methane and carbon dioxide, and this was the first time in history that carbon-based molecules were found on an exoplanet within the habitable zone. First of all, this matched the theoretical concept of a Hycean planet very well, since in a hydrogen-rich atmosphere, molecules like methane are expected. And also, the ratios of different compounds in the atmosphere ruled out other scenarios like mini-Neptunes or gas dwarfs. So, the researchers basically confirmed their assumptions about the nature of this world and are now confidently calling it a Hycean planet, even though no water vapor was actually found. They explained that water vapor should condense at the altitudes probed by transmission spectroscopy, which is why it didn't appear in the spectrum. Secondly, and even more intriguing, was the hint of dimethyl sulfide, a molecule that, as far as we know, is only produced by living organisms on Earth, mostly by phytoplankton. Yes, the signal was extremely weak and by no means conclusive, but still, this was a potential biosignature detection in the atmosphere of another planet. And now, finally, on April 17, 2025, Madhusudan and his colleagues announced a new round of spectroscopy on K2-18b, and this time, they got much stronger chemical signs of potential life. At least, that's how it's being reported all over the internet. The first thing that makes us look at this study with some optimism is the fact that the approach to determining the chemical composition of the atmosphere was slightly different this time. Previously, the team used 2 of Webb's instruments, the near-infrared camera and the near-infrared spectrograph. That means their data was limited to the near-infrared range. But this time, they observed the planet using a different instrument, MIRI, which sees the universe in the mid-infrared spectrum. And the result turned out to be very interesting. In their study, the authors mentioned that they were looking for 20 different molecules considered to be potential biosignatures, but the observed spectrum matched best with only 2, dimethyl sulfide and dimethyl disulfide. These are molecules from the same chemical group, and since on Earth they are only produced by living organisms, they are considered potentially the strongest biosignatures. In fact, the concentration of these compounds on Earth is about 1 part per billion, while on K218b, it's over 10 parts per million. That means there's 1,000 times more of this substance on that planet than on Earth. Once again, we are talking about the potential detection of biosignature molecules, not life itself. That's an important distinction. The fact that different instruments, working in different wavelengths, independently produced similar data, that's a good result. The authors emphasize that the signal was indeed strong and clear. Here on this diagram, you can see approximately what it looks like. The blue line is the model that includes the 2 chemical compounds, and the yellow dots are the actual observation data from the MIRI instrument. By the way, these little bars next to the dots show the possible margin of error, but overall, the shape of the spectrum, as you can see, is very similar to the model. So then, did we just find a marker of life or not? Well, let's start with the bad news and then move on to the positive. Importantly, the authors report the detection of these 2 types of molecules at a statistical significance level of 3 sigma. This corresponds to a probability of 3 in 1,000 that the signal is a false positive. However, the gold standard in science is still 5 sigma, where the chance of error drops to just 1 in 3.5 million. So what does this mean in practice? It means that the results are currently at the lower edge of scientific reliability, so this is not yet a confirmed discovery. In fact, the authors of the study also emphasize this. They are very cautious in their conclusions and treat their own results with skepticism, saying that more checks and rechecks are needed before they can be completely confident. That's why Madhusudan says that between 16 and 24 additional hours of observation would give them the 5 sigma level of certainty they need. However, not everyone shares his optimism. The magazine New Scientist, for example, quotes several scientists who are skeptical, not just about the discovery itself, but even about the possibility of ever reaching 5 sigma for this planet. Even with a large, puffy atmosphere and a relatively close distance, spectral analysis is still not an easy task. For instance, Thomas Beatty from the University of Wisconsin compares the thickness of the atmosphere relative to the size of the planet to the thickness of apple skin relative to the apple itself. It's true, the signal in question could represent just 0.1% of the entire dataset from the spectrum. In other words, there could be so much noise in the data that even with 24 extra hours, reaching 5 sigma might be overly optimistic. But let's imagine for a moment, what if this confirmation does happen? Could we then say that scientists have discovered extraterrestrial life? Well, yes. Dimethyl sulfide is considered a biosignature because its potential role in the search for life has been discussed in several previous studies. So, its detection in hydrogen-rich atmospheres, like those found on super-Earths, could be a sign of life. It could be, but it's not necessarily proof. The fact that on Earth this compound is produced exclusively by living organisms does not mean that some kind of abiotic process couldn't exist somewhere else in the universe. Exoplanets are incredibly diverse, and the truth is, we have no real idea what chemical reactions might be possible on those distant worlds. What if the dimethyl sulfide molecule is simply formed through photochemical processes in hydrogen-rich atmospheres? What's more, this molecule, dimethyl sulfide, has already been found beyond Earth. For example, on the surface of Comet 67P Churyumov-Gerasimenko. In March of last year, a group of scientists reported that they found this compound in archival data from the Rosetta spacecraft, in the dust and gas surrounding one of the most well-known comets. And clearly, a cold, dead comet is not exactly the ideal place for life, not even microbial life. So this looks like the first real clue pointing to an abiotic origin for the molecule. And yes, I understand, now we're talking about a much broader issue, not just this particular study. The real question is, can we trust the molecules we call biosignatures? It seems astronomers will have to tackle this problem before we can seriously search for life around other stars. One more thing, and this is just a personal observation. Something that made me a little more skeptical about this study is the fact that almost all the science related to this planet is being done by a single team. When you open a paper and see that the authors mostly cite themselves, meaning only their own previous work, it's hard not to feel a bit of doubt creeping in. Sure, that could just mean the research area is very narrow and not many others are working on it. That's totally possible. But to me, that's still a bit of a downside. Everyone benefits when multiple independent teams work on the same problem. Again, that's just my subjective opinion, and I absolutely don't want to downplay the author's contribution. They've done truly fantastic work. And in fact, here's the positive part of this story. Astronomers have come closer to what, just a few decades ago, would have sounded like pure science fiction. They're analyzing the atmospheres of distant planets, even ones just a bit larger than Earth, and they're already detecting potential hints of biosignatures. Just think about that. A couple of decades ago, people were amazed that we could even find a planet around another star. And now, we're saying, meh, it's just another planet. Show us signs of life. It's not that our expectations have grown, it's that we've witnessed a jaw-dropping leap in exoplanet science. A young field of astronomy, but one of the most exciting. So, here's my personal take. This is a fascinating and incredibly motivating piece of work by Madhusudhan and his team. But as even he says, there's still a long way to go before we can call any planet habitable, let alone inhabited. It's amazing that science has already reached this point. And yes, this result really does give us hope. But no, we haven't found alien life just yet. We're not there, but we're definitely closer than ever before. Thank you, friends. If you enjoyed this, please subscribe to the channel. It'd mean a lot if you hit the like button and share your thoughts in the comments. What do you think about everything we've just talked about? That's all for today. Take care of yourselves, and I'll see you in the next episode.